Okay, so I think all of you are there. So let me start ahead. है ना? So I was discussing some applications. We are going in a very rough manner today. है ना? So you need not worry. Today we are just trying to develop an interest in our studies. And in the last, we will have one topic, if the time allows, that is what is fluid. That topic will give you 4 objective points for GATE exam. 4 objective points in a single topic. Okay. So let's see if we are able to reach there. I think we will easily do it. But the topic itself requires some time. So we will see how much time is left with us. So we discussed some examples like we need to understand, if we need to understand fluid human body or matlab body of animals, then fluid mechanics is important. Not only this, but in plants also we need to understand fluid mechanics to understand the rise of sap in the stems and all that. Okay, osmosis, reverse osmosis. Then for understanding nature, you need to understand fluid mechanics because nature is mainly fluid mechanics. And then we discussed about power generation. So hydroelectric power plants are made mainly on the concept of fluid mechanics. But it's not only hydroelectric power plant, but whether it's a steam power plant or a nuclear power plant or wind energy system, almost geothermal energy system, almost all the systems are based on fluid mechanics in some aspect. For example, when you burn coal, heat is produced, and with the help of that heat, you convert water into steam. Now the high pressure steam is passed on to the turbines and power is produced. But for this flow of steam from the boiler to the turbine, then flow of steam from the turbine to the condenser, from condenser to pump, then water from pump to boiler. For this entire flow, you need to understand fluid mechanics, because what you will say is that from boiler to turbine, this is the length of the pipe. This is the friction factor in the pipe. The pressure at the inlet of pipe is this, pressure at the outlet of pipe is this. So from inlet to outlet, when the fluid will flow, when the steam will move from the boiler to the turbine, there will be a loss of mechanical energy. So for calculating this wastage, for maintaining this flow, you require fluid mechanics. And definitely for design of turbines and pumps, in the steam power plant or nuclear power plant, you require fluid mechanics. So it's almost everywhere. Now, this is a very interesting example. So example mainly belongs to mechanical engineering, but the same procedure is used in civil engineering also while designing irrigation channels or skyscrapers. Let's see what the example is. So there is a video. I hope you are able to see the video on your screens. Yes, steam is a fluid. We will discuss the definition of fluid. It is compressible. That is also true. Steam is compressible. So are you able to see the video, guys? Okay, so I think they are showing the lights of a car. Basically, this car is inside a tunnel, and in front of that car there is a fan, and that fan is releasing some smoke. So these white lines, these white lines which you are able to see, actually these are smoke lines. These are streamlines, streak lines and path lines which you will study in fluid kinematics. And can anyone tell me what these guys are doing? Huh? Any idea what these guys are doing? Wind tunnel, very good. Aerodynamic testing. Arey wow, very good, Swapnil. So very good. So basically what they say is, let me show you the idea. So suppose there is a car. All of you, all the engineers, my favorite engineers, mechanical and civil engineers, have a look. By the way, you know we rule the world. Without us there is nothing. Even then we are paid less. Don't worry. But government jobs pay us high. That's why we are looking for GATE exam. So what we have is, we have a car. So actually when the car moves, with respect to the car, the air moves in the backward direction, right? So with respect to car, the air is moving in the backward direction. Now some of the air will move like this, right? And some of it will move like this. But what will happen? In the front portion, the air will strike with it. like this, and some turbulence will be generated, and on the surface of the car there will be an additional pressure which you call as dynamic pressure. You call it as what? Dynamic pressure. Do not worry, we will discuss all these terms. Now what this dynamic pressure is doing, it is opposing the motion of the car. Am I right? Hai? When the car will move ahead, basically the air is striking with it. So air will apply some force on it. That will be a dynamic force. We are not going to calculate dynamic force in our syllabus, by the way. Is that right? Hai? Now this dynamic force, is it opposing the motion of the car or promoting it? Guys, when you will move in water, suppose you are standing in swimming pool and you are moving in swimming pool, the water will oppose you or promote you? It will oppose us. Very good. Hai? So there is an opposing force over here. Okay. Similarly, at the back end, some vacuum is created. Okay. This is something like flow detachment or boundary layer separation in simple terms. Flow detachment. कुछ होता है, ठीक है? Do not worry, I will tell you these things as the time will come. So some partial vacuum is created over there. So there is an extra push, okay? And not only this, when two solid bodies move with respect to one another, there is friction force. Similarly, when air moves with respect to solid surface, there is friction force. Now check, air is moving in this direction. On the air, the friction force will act in backward direction like this. So on the solid surface, the friction force will act in this direction. Hai? So how do you represent friction force per unit area? By shear stress. Now this shear stress is also going to oppose the motion of the car. So what we have is, we have some dynamic pressure at the front, we have some viscous stress on the surface of the car, and then we have some vacuum. All these forces are going to oppose the motion of the body, and this opposition is known as drag. This is known as what? Drag. Now in the early, I think I have deleted that slide. Okay. In the beginning of automobile industry, the cars had a box type shape, hai? Like this one. So generally the cars had a shape like this, box type shape. So when we have a shape like this, actually this drag force, that is the opposing force, is very high. Okay. But this drag force is directly proportional to square of velocity. Whose velocity? Car velocity. And initially, what was the speed of car? Ford Model T, that is the car in the very beginning, the one of the first cars. It had a maximum speed of 35 km per hour. It's not a very big value. So these values were very small. Therefore, drag force was also very small. But nowadays, even our bikes, they are running at a speed of 120 km per hour. We want the Ferraris to run at 200 km per hour. We cannot do it on Indian roads, but outside the sports cars are running at these much speeds. So when the velocity is very high, this drag is going to be very high. Now what is drag? Drag is opposing force. So opposing force will consume some energy. So actually this drag will increase the fuel consumption significantly. Okay? And definitely the drag is going to slow down the car. So it will also reduce the velocity and acceleration of the car. So to have a higher velocity, a higher acceleration and a lower fuel consumption, we need to reduce this drag. And that's why we do this video. What is this video? This video is nothing but it is wind tunnel testing. Actually, this wind tunnel testing helps us to determine what is the relationship between tau and what is the relationship between the drag and the shape of the car. Okay. This wind tunnel testing helps you what? It helps you to understand the relationship between the drag and the shape of the car. So basically with help of these experiments, you can optimize the shape of the car and then minimize the drag. So I will discuss this in fluid kinematics. Okay, I will try to explain you the whole procedure in fluid kinematics. But that will depend on how much time we have. Okay, so related to that experiment which was going on in the video, that is wind tunnel testing of the car. Okay, In that testing, there are some terms like streamline, streak line, path line, stream function, velocity potential function. So these terms we will discuss. In that experiment, there are some other terms also, that is optical scalarians, vector plots, contour plots, and then there is one more term, I just forgot it, shadow graphs. Okay, so these are some methods which help you develop this relationship. So we will not go very deep. I will just give you a basic idea of the experiment, and then we will understand all the terms related to it. Okay, so this example we will discuss again over there, but with the help of experiments, what we have realized is that final shape of the car should be something like this. This should be the shape of the car. Check how much lengthy is the front bumper, and instead of boxy structure like this, the car has a very smooth transition like this. And then on the back side, the tail is extending too much behind the wheel. Is it right? Also what they have done is, they have kept the clearance of the car very small. The clearance of the car is very small. And this is something known as fast back profile. It's known as what? Fast back profile. And sometimes what you do is, here you add a spoiler also, or you give some wing to the car. Sometimes we do this. Then sometimes we give a side skirt also. And also sometimes in the front there are splitters. So a lot of things are there. When you say modified the car, अरे उसने अपनी car modify करा ली. In Fast and Furious there were so many modified cars. So modified cars, they not only have modified engines, but they have modified bodies also, like spoilers, wings, skirts, splitters, all these things, vortex generators, air diffusers. So all this knowledge has come from wind tunnel testing only, that how to modify the shape and minimize the drag and maximize the grip, maximize the traction. Okay, and check what these guys are doing. They will now add a modification in the car. Now check, all of you have a look at the video. So in the video, the tail of the car will extend. This is to reduce the vacuum behind the car. Check, within a few seconds the tail of the car will expand, just to reduce the vacuum and minimize the drag. And why we want to minimize the drag? To increase the velocity, to increase the acceleration, to reduce the fuel consumption, to increase the grip during cornering and all that. Check, the tail of the car is expanding now. I think the video is getting stuck, so we will not waste much time on it. Just have a look, the tail is expanding. I hope you are able to see it. Now they are showing the expanding tail, right? And this is what they are doing. So all this information has come from fluid mechanics. So you can simply say developing the aerodynamics of the car, that comes from fluid mechanics. And not only that of car, but of a skyscraper also. So big skyscrapers like Twin Towers, Petronas Towers, or Shanghai Tower, then World Trade Centers were there. So all these, or Antilia is there. So all Antilia means the house of Mr. Mukesh Ambani, $1 billion building. I hope civil engineers know about this. So these big buildings, they are exposed to too much amount of wind load, because of their height and too much large surface area. So against the building, when the wind will blow, it will apply some dynamic pressure. Now dynamic pressure into area will become the force. So on the skyscraper, there is some loading, so there will be some shear force, bending moment and deflection also. So you have to design the building in such a way that it is a little flexible and it is able to bear these loads. So to find out the load first, you have to understand fluid mechanics. So even in design of skyscrapers, we are doing these testings for predicting these loads. So these things are used not only in mechanical engineering, but in civil engineering also. But for mechanical engineers, I have a question, okay? Mechanical engineers, fluid mechanics for automobiles, is it limited to aerodynamic design only? Or in automobiles, is there somewhere else also where we are using fluid mechanics? Shrimay, actually, by extending the tail. We call it as tail. By extending the tail, actually you will reduce the drag on the car. And if the drag force will reduce, the velocity, acceleration and will increase. And power consumption will decrease. Very good. So hydraulic brakes, very good braking system. But most important, my product, the product which I was developing, air intake systems, fuel injection, very good. Hydraulic brakes, very good. Okay, so let's check. So actually, not only the outer body, but in fact the engine is very much based on fluid mechanics. First of all, the air will come inside, it will pass through the air filter. From the air filter, it will go into the air intake manifold. In the air intake manifold, the petrol or CNG will be injected. Now the mixture, so basically the flow should be turbulent so that the mixture formation is uniform. Now this mixture moves into the combustion chamber where the burning happens. So to make to allow proper amount of fuel going inside the combustion chamber, this flow should be proper. Okay, basically what I am trying to say is that for every cycle there is a discharge to the combustion chamber, and if you do not design this air intake system in a proper manner means the size of the components, the length of the components, the pressure drop in the components, you will not get a proper discharge and you will not get a proper power production. So inside the automobile engine, whatever flow is there, whether it is air intake system or exhaust system, that is all based on fluid mechanics. Then not only this, nowadays your hydraulic brakes, your brakes are hydraulic. They are working on Pascal's law only. Power steering working on Pascal's law only. So we will see the structure of your brakes. We will see the structure of power steering in second chapter. I will show you there. Okay. So all these devices are based on fluid mechanics. So it is a very important part of your automobile system. And since we are talking of automobile system, automobiles, this is a car known as, basically from here it started, Tatra 77. This is the first car which was developed using aerodynamics. Aerodynamics means studying the flow of air against solid bodies. So that is a branch of fluid mechanics only. And then we have reached over here. This car is the most aerodynamic car in the world. It's Volkswagen XL1. It came out in 2014, I think. And the video which I showed you, that is Mercedes-Benz ILA concept. But this is the car with the minimum drag force. Okay. So a lot of things are there, and our aeroplanes, they are also based on fluid mechanics. So the procedure is very similar. So when we are going to do fluid kinematics, I will show you the procedure of how they design aeroplanes. So it is only fluid mechanics which is going to make them fly, and not only going to make them fly, but actually even their maneuvering means you want to turn the aeroplane to the left or right. Okay, so for turning them, aeroplane has to go like this, it has to go like this, it has to go up, it has to go down. So for turning them, see the wings of the aeroplane. It has movable parts, flaps, slats, ailerons, and check the other things. Rudder is there, elevator is there. So these flaps, actually all these things basically help the aeroplane to change directions. So their design is also based on fluid mechanics, and definitely like the engine of an automobile, the engine of an aeroplane is also based on fluid mechanics. You are going to have a turbine, you are going to have a compressor, which are going to have a rotor and a blade. So all these things are based on fluid mechanics. You can go to ships, submarines, their layout, that is fluid mechanics only. And like this, a lot of examples are there. Now check, I was talking about wind tunnel testing of buildings. So in the wind tunnel, they have placed a model of a building. They are going to test. So I was not lying. You can check on internet also. So a lot of things are there in construction equipment. So for civil engineers, the construction equipment are their backbones. But can you see a piston cylinder on the arm of this construction equipment, guys? Have a look. There is a JCB kind of thing. It's a Komatsu company. So on the arm, there is a piston cylinder. That is Pascal's law only. मैं वहीं बताऊंगा, ठीक है? जब chapter आएगा, in the chapter only I will show you that muscle power of construction equipment or tunnel boring machine, all that comes from fluid mechanics. So check, from making a water tank in your home, to a submarine or an aircraft carrier. How much does a water tank cost? Syntax tank. It costs only about 5,000 rupees. But how much an aircraft carrier costs? It costs you around 2 lakh crores. So from making something that has only 5,000 rupees cost to something which has 2 lakh crore cost, everywhere fluid mechanics is involved. Okay. And what we will do is that with every chapter we will try to discuss some applications, and if possible even numericals I will try to give you in form of applications, but mainly the numericals will be theory based. I mean gate oriented. The numericals will be gate oriented, types of numericals which are asked in gate exams, and definitely we will do last 30-year gate question papers also. So if I keep on moving, the list will be very large, so it's better to switch this off, applications, and move on to the next part of fluid mechanics. So till now what I have told you is the scope and application of the subject, but now the main thing comes, that is what are the topics to be studied in GATE exam, and we will start with the first chapter, that is introduction and fluid properties. Okay, so you can note down the index of fluid mechanics.